You're listening to Don't Waste Water.
We're building deep tech with a hardware component. In terms of how investable we are, it feels like we tick all the wrong boxes of don't do these things.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
We're able to hit down to single part per trillion level of detection for the different analytes and have good reproducibility that falls within the performance metrics of the method.
I'm your host, Antoine Walter, and in today's episode, I'm delighted to welcome Emily Hicks as my guest.
By far, PFAS was the biggest opportunity. Unlike all of the other opportunities where it was, there's an opportunity for this, one for this, one for this. It was PFAS was like 10 times all of those.
Emily is the Chief Operating Officer and co-founder of FREDsense.
PFAS is sticky. It's not something that you just take out and you're good to go. There's definitely rebound that people are seeing once you clean something out, you put it back in service, the PFAS starts to come back out. So you really want to make sure you're doing it well. And so that was kind of what we were using the field kit for.
FREDsense accelerates your PFAS mitigation decision-making, projects, and technology development through the world's first on-site PFAS field kit and 5-day PFAS lab analysis services.
Oftentimes we'll get a customer that's like, I need to measure PFAS. I don't know how. I don't know what I need. What kind of tests are there? What do those show? Does this one mean more than this one? I'm not really sure. Do I want that? Do I want this? They don't know. And so we also spend a lot of time trying to help them. Okay, what are you trying to do? What do you need? We can help you figure that out.
And before we start, let me thank my sponsors, Simple Lab and Bluefoot Membranes.
PFAS is not straightforward at all. There are so many different analytes. There's a lot of noise in the market.
There would be much to say about the American Water Works Association's lawsuit against the US PFAS regulation, and I might specifically look into it somewhere down the line, but for today, I believe there are some very revealing elements in it that apply to all geographies currently deploying approaches to remove PFAS from tap water, and those elements revolve around analytics and operations. Tracking specific PFAS compounds at single-digit parts per trillion concentration is, let me use the euphemism of the year, not easy. While we all instinctively know that gas or liquid chromatography associated with mass spectrometry is not something you do in your garage, the AWWA's petition sheds some light on the scale of rarity we're discussing here. Today, only 54 labs are certified in the US to run the now mandatory PFAS screening and monitoring samples. If you compare that to the about 5,400 utilities that will have to inquire those services up to 4 times a year, you get a sense of the issue. And don't believe the situation is easier in Europe. As an anecdote, 2 years ago, I tried running an investigation on PFAS in tap water while I still lived in France, but as the 8 first water laboratories I inquired around me all answered that they did not measure PFAS, honestly, I gave up. I can give up. I'm producing content. A utility can't give up if the law says they have to run the analysis. And that's how the AWWA estimates that this will mean nearly 5,000 samples per lab and per month that will have to be processed. Quite a workload, right? And as a result, they estimate it will cost $300 to $375 per sample for turnaround times somewhere between 1 and 3 months. Maybe I should tell them about Simple Lab. But jokes aside, there is a way around. Buy your own equipment, right? Well, still according to the association, you'll have to account for $500,000 for that alone. And then you'll have to train your team. And that is still only for monitoring, because if you go to the next step and you're now removing PFAS, well, you can't blindly operate your activated carbon or ion exchange filter. Running those with one analysis a quarter would be like driving your car, sure, on a straight highway, but with your hand in front of your eyes and never any sight of what's in front, and just an occasional look in the mirror. I doubt that would be very safe. So, still in the petition, the AWWA estimates that a running plant will need to send 500 to 720 samples per year just to ensure they're not blind on what they're doing. And if you multiply that by the projected 8,000 PFAS removal systems that are planned to be implemented, that adds nearly 5 million samples a year. Now, last but not least, what often makes the headlines in the legal dispute between the AWWA and the EPA is the projected cost of implementing PFAS removal. But what I believe is overlooked is the reason why the cost estimates diverge so strongly. And there, hidden in plain sight, there's a very interesting one. The EPA recommends as a best practice to aim at reducing PFAS levels up until they reach 80% of the legal threshold. To do so, you can blend fully treated water with water that's got some level of PFAS inside, so that the blend is at or under 80%. That's a potential huge saving. Less water running through your activated carbon or ion exchange means longer lifetime for the media, or less skids needed, or smaller ones. And if you do that, you can reduce CapEx and OpEx. But what the AWWA says is, good idea, folks. We thought of that as well, but to reach 80% while remaining confident enough I never crossed the 100% bar, I will need much better analytics and faster turnarounds, and even like that, I will need to be safer and aim for 50% of the target, which mechanically increases CapEx and OpEx by nearly 40%. So you see, the PFAS analytics question is instrumental, pun intended, in the economic plausibility of PFAS removal happening at scale, and that is even more true for PFAS destruction. Hence, I'm absolutely sure you'll crave this week's conversation as you'll learn how FREDsense delivers PFAS testing in 5 days through their biosensor technology, but also how they bootstrapped their journey from 25k water bottle crowdfunding campaigns to pioneering field PFAS detection kits, while the company pivoted from arsenic and COVID detection to focusing purely on PFAS chemistry and unmet market needs, how polymer-based biosensors will make on-site PFAS testing possible down to parts per trillion levels, but also strategic partnerships with treatment rockstars like Aclarity, Axine or Ovivo, and much more. As always, if you enjoyed this conversation, please take this episode and share it with a colleague, a friend, your boss, or your team. Make sure to subscribe, and I'll meet you on the other side. Hi, Emily. Welcome to the show.
Hello. Thanks for having me.
I have to say it's an absolute premiere, first time ever that I have an interview at home. I tried to look if there is anyone else in your lane, and trust me, I've been looking in great depth. Like, I've been harassing companies doing sensor and saying, hey, by the way, do you also do PFAS? And everybody looks at me and says, we would love to, but it's not possible. And then there's FREDsense. So I'm super curious to understand how you do what no one else is able to do. But before we jump into your solution, I want to discuss the problem, because every time I meet a utility, they say, we have now that mandate to measure PFAS, and we would love to measure PFAS. The thing is that it takes weeks. And if we do it internally, it's like super expensive, super complex. So is that the status quo? Or is my due diligence in that not complete enough?
No, I think that's definitely the status quo, is that it's still quite hard. It's done generally in a lab. Like, we're kind of the first field kit that exists. So everything that's done today is in a lab. There are more labs doing PFAS now. So definitely that was not true a while ago. But now there's, lots of labs that have got into the PFAS game. But I'd say it's still pretty slow. And even labs that kind of offer more rush turnaround times, whether or not they can actually deliver on that is always another question. It's not uncommon, with projects that we work on. Oftentimes when we're developing, deploying our field kit, a customer might be sending samples as well to a third-party lab. And it's not uncommon for that process to take a month at least to get data back, even for, a large company and not in a rural setting. That's still pretty normal.
I was in a session with Orange County and Denver Water, which I would estimate to be like some of the best utilities probably there are. And they were talking of 5 weeks.
Yep.
And you do it in 5 days.
We do. Yeah.
What's the trick?
A couple things. The first is that we just do PFAS. So unlike a lot of labs that are set up to do all sorts of different parameters, we just do PFAS. So everything that we do is just for PFAS analysis. So it's pretty streamlined. We don't have to compete for instrument time. We also are not accredited, which has been a somewhat strategic decision at the moment for us, because we're really in this rush turnaround game. So we provide very high quality analysis. We've done proficiency samples, tests on that to show that our testing is, comparable to the bigger labs, but we're not accredited. So that, saves us a little bit of time on some of the reporting criteria for that kind of thing. But I think it's really just that we're super streamlined and we just do PFAS. And we've really tried to simplify the process as much as possible in terms of how customers send us samples, how we get them in the lab, how we get them into our system, how we batch the analyses that we do, and how we get the reporting done. And I think that's really why we're able to be, so quick.
You're not accredited. That means that you don't follow all the paperwork which has to be done for accreditation. You offer something which is top-notch, but someone who gets your results, does it change something for them that you're not accredited?
So it can. It depends on the application. If you're a utility that needs to do specific reporting to a certain state body or something like that, there's a chance that you're going to need an accredited lab to do that testing. And that's kind of just a stamp of approval that this lab is legit. You didn't just send it to some guy in his basement who says it's fine. You can imagine that, for a lot of reasons, there's kind of some checks and balances on those kind of things, especially if you're dealing with a utility or some kind of, public water source or something like that. So there's definitely places where accreditation is important. Sometimes if you're doing, you're a DoD site or you're doing a project where there's eventually some kind of release or something like that, you might need to use an accredited lab. But what we find is there's also lots of cases where you wouldn't necessarily need to use an accredited lab. We work a lot. One of our big customer segments for our rush turnaround lab is technology providers. So people that are working on PFAS treatment, and they might be doing a pilot in the field. They might be doing testing in their R&D lab. They might be doing all sorts of different testing, different consumables, whatever it is. And for that, they don't necessarily need compliance-based results. They might need it for maybe the very final sample of their pilot, but they probably don't need it for all of the optimization steps. And so it's really just a gold stamp that says that, you followed all the rules. We're still very confident in our data. We don't think our data is any different from any of the compliance labs, but because we haven't gone through that step to get accredited, we can't be used for some very specific applications where you would need an accredited result.
We'll go into the full depth of how that works. Just give us a teaser. What's the level of accuracy which you can reach?
We do general EPA analyses. We do 1633, 537.1, and we have really good accuracy and precision in line with the method. So we see recoveries within the acceptable ranges. For those, we're able to hit down to single part per trillion level of detection for the different analyte and have good reproducibility that falls within the performance metrics of the method. It's a very vague answer to the question. With a 40 analyte list, it's hard to, there's obviously a specific, precision and recovery for each individual analyte. And that's a lot to know, but we fall within what the EPA is considered acceptable for 1633.
When you say single parts per trillion, I think everybody gets an idea of what we're discussing here. So
exactly.
It's very, very clear. PFAS is what you do today. If I go back in time, when you created FREDsense, had you ever heard of the word PFAS?
No, definitely not. So when we created FREDsense, our very first sensor that we were working on developing was for oil and gas contaminants. We were looking at a specific class of contaminants called naphthenic acids, and we were building a biological sensor to measure those. Did that for a little bit when we very first started the company, and then, started to do a lot of market analysis and really found out that it was a bit of a niche problem. Like there was definitely a lot of interest in it, especially in the academic sphere, but there wasn't always a really tangible, what do you do about it? It wasn't something where you get a measurement and you can really quickly action something that changes something. So getting that data fast is important. It's often something that you might be monitoring, monthly or quarterly, but there's not really an action that you're taking. So even if it takes, a month or 2 months to get the data back, it doesn't really change the answer. And so ended up pivoting from that and started to get into arsenic analysis. And arsenic was super interesting because we were looking for an analyte where measuring just one thing would be super valuable, because when you think about water quality, depending on your application, you might need to measure 5 things or 10 things. And if we can measure 1 or 2 of those things for you, but you have to send the rest of those 8 of those things to the lab, that's not tremendously valuable for you. And so arsenic was really interesting because it was a single parameter. There was a big problem to a lot of utilities, and it was something where a lot of utilities have active treatment systems in place, but they don't have good ways to measure it. And so they're still relying, even fairly large utilities still often rely on third-party labs to get their data back, and it can take a month to get your arsenic data back, which if you're thinking about streamlining your remediation process, it's not terribly effective.
Yeah.
And so it was a really interesting market, did that for quite a while of time, found that COVID, really had to put a damper on how we were servicing that market. We were doing a lot of in-person pilots. We'd go down, use it in their water, show them the value of it, and all of that, really kind of shut down during COVID. And so we ended up still continuing with that, but we pivoted to doing COVID-19 detection in wastewater and created a portable unit to measure COVID-19, had really good success with that, and we're really kind of getting somewhere just as that market kind of changed, which we always knew was going to happen, but it very much became something that was going to be more done by an academic group, university, by a government group. It wasn't really something that a for-profit company, was really doing. It was more like a citizen science academic groups that are starting to build, because people still monitor some of that stuff today in wastewater, but it's not really a huge market opportunity. So, at that point, we were kind of looking like, okay, we're, continuing on the arsenic side of things, but looking into the future, because arsenic was always a relatively small market opportunity that we saw. What else can we do? And so we sat down and did a big market analysis. We did some work with Blue Tech to kind of look out at the market, what's out there. And really the big thing that came back was PFAS. By far, PFAS was the biggest opportunity, unlike all of the other opportunities where it was, there's an opportunity for this, one for this, one for this. It was like PFAS was like 10 times all of those. And so that kind of got us thinking, could we do PFAS? And we had done this interesting project with the Canadian Food Inspection Agency to look at marine shellfish toxins. And we had developed an antibody-based system to measure these shellfish toxins. And so we were thinking, could we pivot this antibody-based system to measure PFAS? And so it started out as this really small little project. We had a couple people working on it, just wanted to see if it would work, and it did. And so we got some interesting results. And then, over about a 12-month period, ended up, PFAS was a small little project. And over time, it became all that we were doing. And we ended up opening the service lab and pretty much pivoting everyone in the company to be almost exclusively focused on PFAS.
So that means that even the arsenic part doesn't exist anymore. You do PFAS.
Yeah, it still exists, but we really aren't servicing that market. It's just we really need to get to a scale on that side, like a much larger scale, being able to look at distribution channels, that kind of thing, for that to really make sense. And just the timeliness of the PFAS opportunity, is just so compelling that we decided to really, put our resources in PFAS because that's where we see the most opportunity at the moment. And we think arsenic's something that we'll definitely come back to. Like, we have a developed technology, it works well, it has a strong value prop. But in order to kind of get us more sustainable, we really wanted to focus on the big opportunity first.
On the PFAS opportunity itself, if I try to compare you to everything I've seen in that market, you are taking quite a different approach. You would see people playing around with boron-doped electrodes or very, very specific high-end electrodes.
Yep.
If I get you, you are doing a fluorescence approach.
Yep.
And I'd like to understand why you go down that one and if everybody's wrong and you're the only right.
Yeah, I think it just depends on what you're trying to get to, really. And for us, our goal, coming out of arsenic and COVID and all the things that we built, what we really developed expertise around was building these field systems, like things that you could use in the field. And we saw that as a big opportunity for something that's portable, you can take it anywhere, and it's relatively easy to use. Like, anyone can do this analysis. And so when you think about some of the other systems, like I know there's groups that are working on, mobile LCMS units and things like that. And there's probably a place for that. You have a site where maybe you have a service lab on site in a trailer that can do analysis. Maybe that makes a lot of sense. But we kind of saw this opening in the market for site investigations, for pilots, for things where you really need that immediacy of the data. And in a portable format, we saw that as being something that was really needed. And so we see ourselves as a screening tool. We're probably not going to be as accurate as a portable LCMS system is ever going to be. But if we can be accurate enough that people can get meaningful data in, a couple hours, we think that there's a really big opportunity there. So I think it's more just around we kind of see ourselves as a screening tool that can be used, quickly on site. I see other technologies that are maybe filling a little bit of a different niche in that market.
So how does it work for the nerd? Like really?
So it's a pretty simple technology. So we've pivoted a few times. So we started out with an antibody-based system, and then we've moved to a bio-inspired polymer. So it's a polymer based on a plant material that we have developed and done some customization on, and that binds PFAS. And it's quite selective to PFAS, and it binds it, and when it binds, it displaces a fluorescent dye, and that fluorescent dye is what we measure. And so we actually measure a drop-in signal, and we're able to correlate that to the amount of PFAS in a sample. Obviously, the challenge of PFAS is that we need to measure it in PPT levels of detection, which is quite challenging for a field kit. I will say, for people that don't know a lot about, sensors that exist, if you look at a lot of the colorimetric sensors that you might buy from a Hawk or another supplier for things in your swimming pool, chlorine, different chemicals, those are usually in ppm or parts per thousand level detection. We're talking PPT. We thought arsenic at ppb was a a step change, and now we're one order of magnitude lower. So we also have a concentration system, and that was kind of some expertise we developed during COVID of getting the COVID out of fecal matter and wastewater samples, being able to extract that. We've repurposed that to be able to extract the PFAS from a sample, concentrate it. So we actually heat it up, evaporate it, and then reconstitute it in a really small volume. And then we feed that into the polymer.
So that means that you're aiming for something which is a good indication, but you will never aim at saying it's an absolute 2.3 PPT, because that's not the use case.
Yeah, exactly. And even in the PFAS field, I would say that that's a 2.3 PPT is already a bit of a stretch. If you look at the EPA, 1633, you look at the acceptance criteria for the recoveries for different analytes, they're between 65 and 135%. So that already tells you, especially in a complicated sample, you're already at a lab seeing a certain level of data. So the fact that, a field kit, you can't really expect to compete better than something in the lab. We're never going to get better than that. But we do think we can get at least fairly comparable. And some of the results we have in the field, do suggest that we're fairly close.
So in terms of field kit, how easy is it to use? Someone stupid, again, like me, can go out, take a sample, measure it, it, if I read the instructions, I'm able to do it?
Yeah, it's fairly simple. We have some good educational material to show you how to do it. Our sales guys can do it. We say that that's a pretty good marker of success. No jab at them, but we've got lots of people in the company to do it. We have actual operators that we've trained, been able to do it. It's a little bit time consuming because of this concentration step, because we have to dry the PFAS down and reconstitute it. That takes some time, but it's all relatively simple steps. It's pouring, it's, letting something dry, it's adding something in. It's nothing really complicated.
So when you say time consuming, how long does it take?
So the whole test takes about 3 hours.
Okay.
Yeah.
Okay. That's not time consuming. That's super fast compared to
a lab.
Which is
and you can do a couple samples at a time. So in a day, you could definitely get 16, 20 samples done.
Sorry to interrupt, but as we were talking about fast turnarounds, I wanted to quickly thank my sponsor, Simple Lab. If you're in the water industry, Simple Lab has you covered. Simple Lab is your one-stop shop for certified laboratory testing kits, from routine lead sampling to walk-ins and specialized analyses like microplastics, PFAS, and RADs. Order the testing you want online, choose from hundreds of accredited commercial labs, get free round-trip shipping both ways, and by the way, if you have your own lab and just want help with kitting and logistics, Simple Lab can do that for you too. No more coordinating labs, chasing shipments, or wrangling EDDs, just streamlined ordering, clear results, and real support when you need it. It's lab testing simplified. Head to gosimplelab.com, it's the first link in the description. Choose your test and they'll take care of the rest. Thanks again, Simple Lab, and back to me.
So if you're reconstructed, how do you say, biosensor is attaching to the PFAS, is attaching to any kind of PFAS, or does it have its favorites?
It definitely has its favorites. That's been a challenge to figure out exactly what it measures. We generally say we can measure anything between about a C4 and a C12 chain. We know that we're not super sensitive for the really short chains. So we know, for example, we don't have great affinity for PFBA, for some of the C3s, and that's largely because of the solid phase extraction process that we use. So the actual concentration part, we're using readily available consumables for that, and they don't have good affinities for some of those.
I see.
We can measure generally a large range of those PFAS. We know we also pick up on precursors. So we consider ourselves more of a total PFAS analysis. So we're definitely picking up on things that are not in a 1633 or a 537.1. We would equate ourselves more to a top measurement, like a total oxidizable precursors or a TOF measurement. But we also know that we're not picking up on some of the fluorine compounds that are not in PFAS. We kind of think about it as, we're more than some of the targeted analyses, but we're not quite as broad as, a TOF analysis.
What is your vision in that? Is that the sensor or the test kit should be capturing everything, or you should be adding one more layer on top of it of, call it whatever's trendy, machine learning, artificial neural networks, or whatever, to bring a sense of the first measure as a proxy. Let's now expand with a bit more water parameters, which are existing in those pens anyway, and let's bind all of that to build an aggregate. Is that part of your vision, or are you saying that we are focused on what we do best?
Yeah, that's definitely something that we're thinking of, and we've been collecting a lot of data on kind of what the speciation patterns look like, what different samples, we have a big database of all of the water quality data for the samples that we measure are. We think that the industry is definitely moving towards more of a total analysis, because we know that just looking at two PFAS parameters like PFOA, PFOS, or just looking at the EPA 6, or just looking at a 537, we know that that's not telling you the whole picture. Even when we think about human health, or we think about assessing how a technology is performing, we know that that's not enough. And so we do think there's a big push to the industry to be able to give a total measurement, and that's really where we think we excel at, whereas other technologies are sometimes a bit more focused. Long term, I could see, definitely some possibilities of having algorithms that can maybe give you an idea of how much certain ones are there, for sure. But we do think that total is going to be a bit more of the way to go, just because there's so many PFAS, it becomes hard to really, pick your favorites of what's really important.
Mentioned the biosensor platform. Is that linked to the conversation I had on that microphone, I think 2 years ago, with Kimberly Kupiecki from Ginkgo Bioworks?
Certainly, we've had some traction in the biosensor space, working with Alonia, working with a company called FREDsense.
Yeah.
This is to develop some very specialized enzymes that will react in a certain way when they're exposed to a particular contaminant, if you will, selenium or whatever else you're looking for, PFAS.
Is that something you did together with Ginkgo, or was that another step which since evolved again?
We did have a partnership with Ginkgo. Haven't done any work with PFAS on that, any work with PFAS. We do have a selenium sensor that we built with Ginkgo that we are still working on. A little bit of the company is working on selenium. We have some funding to do some pilots on that side. So that side's still going ahead. It's just a smaller focus for us right now. But yeah, kind of a little bit of a separate platform for sure.
So the PFAS part is 100% developed in-house?
Yeah.
How do you manage to do that? Because you're really, again, in a different lane from anybody else, which is on one end a blue ocean, awesome
Yeah.
because no competition. And on the other hand, the water sector being the water sector, being alone is usually not a good sign because you will need to have neighbors and competitors so that they help you push it forward. If not, your solution can be the best and still not get adopted. So how do you overcome that?
The reason we were kind of able to develop it is because, even though we don't have PFAS expertise, when we got into PFAS, we'd had at that point like 7 years of experience developing field sensors, and we're able to use a lot of the hardware and pieces and extraction systems that we had developed for other sensors. A lot of that went into the PFAS. And so all of those learnings, all of that expertise, was super critical in helping us get there faster. The actual kind of polymer that we developed, that was kind of some internal brain power that we had of some really smart scientists that were kind of looking into what they thought would be possible. And I think we got lucky in terms of what we were able to produce that worked. But yeah, long term, there's no other products on the market right now other than us, but that's not to say that there aren't lots of competitors emerging. And we know of a lot of groups working on PFAS, and sometimes they're maybe direct competitors of ours, or, they're kind of taking it at a bit of a different approach. Maybe they're just measuring PFOA, PFAS. Maybe they're developing portable LCMS units. Like there's definitely other groups that I think might fill other places in the market. But yeah, I think it'd be naive to think that we'll be the only product in the market for too much longer here. Definitely, there's other groups coming up.
How do you convince people that what you have is legit? I've seen the EPA logo on your website. Okay, that surely helps. But what do you have to prove and what do you have to show?
At this point, we have some data sets that we've produced. We have one, publicly available case study that we published with TRS on an airport cleanout that we did, where we used the technology in the field to show, a cleanout of a fire truck that they were doing at an airport station. And so that's some really good data because that was, with a consultant that was using the technology. We have a couple more of those that are in the queue hoping to publish. So that's, super helpful to give kind of real world examples. We've been fortunate to have some early adopters that have been really willing to work with us closely and get their hands dirty and test things out. It's definitely a barrier. I'd say the nice thing about PFAS is that there's nothing else right now that exists. And so sometimes just having an indicator, people see that as highly valuable for the applications they're doing, even if it's not perfectly comparable to a lab-based analysis, having something is often better than nothing. And so that's definitely working in our favor. But it's a lot of working with customers. We were really fortunate to have some good early customers that are, working with us, sharing data sets, really helping kind of develop this. And so we'll have a lot more data in the future, which I think will make it a lot easier, once we have this under our belt.
Help me build that mental use case. When you're on an airport cleanup, if you don't use FREDsense, you would very probably need to store your water as long as you don't get the results, because if not, you're just discharging PFAS, which is lawful. So here, the alternative is you get the measurement from FREDsense, which is not going to be absolutely binding as per it's below 3 ppt. But if your measurement says there's nothing, then very probably there's nothing and you could let that water flow, minimizing your risk. Is that?
Kind of, yeah. And that's definitely longer term what we see the use case. With this particular one, there's kind of two bits of it. So they're rinsing out the truck. And then what they have to do is they're collecting all of that water. They're actually doing some treatment on site, and then they are waiting to release that. And they did actually wait for actual certified lab analysis to fully release that.
Because it was the first time, or because long-term that's going to be the way?
Just because you're releasing water, you want to make sure that that's, below the limit, which is 4 ppt. We do not have a limit of detection of 4 ppt right now, so we can't really play in that application. But what we could, and longer term, if we can get down to 4 ppt, that's absolutely a place for the field kit. What the other problem, though, is that if you're rinsing out this truck, you have really a strong incentive to get the truck back in circulation, like to get it back doing its job kind of thing. Because if you're an airport, you only have so many fire trucks and you actually legally have to have a certain number in operation to allow the airport to run, or else you have to start to shut down parts of the airport, which obviously is hugely expensive. So they are kind of flying blind though. So oftentimes they'll do a certain number of rinses of the truck and call it a day and they'll be done. And you're not really sure how clean you got the truck because you're not measuring that at all. You'll take a sample, send it to a lab, and then, 4 weeks later when the truck's already back in service, figure out, oh, it wasn't that clean or it was that clean, and so that's kind of the use case that we were helping with, is that on site, are we actually cleaning it out? Because that's really a big question with AFFF changeouts is PFAS is sticky. It's not something that you just take out and you're good to go. There's definitely rebound that people are seeing once you clean something out, you put it back in service, the PFAS starts to come back out. So you really want to make sure you're doing it well. And so that was kind of what we were using the field kit for, is when is it clean? And what we showed in our case study is that they could have probably skipped the last rinse because they were able to hit their target threshold on the 4th rinse of the truck.
That's a field demonstrator that shows what you can do.
Yep.
You also have the lab analysis that come
Yes.
back, which means that you have the direct one-to-one comparison, but it's project-based. Do you have to do some, let's say, silly work or academic work where you simply do like double-blind studies, stuff which is done with your own lab analysis, stuff which is done with your field test, and then something which is done by the accredited lab using GCMS or LCMS, and then you compare?
Yeah, we do a lot of comparison. So oftentimes when we do a pilot, like this particular one that we did with TRS at an airport site, we took the samples and so we measured on the field kit. They send it to their own third-party lab. We sent it to our internal FREDsense lab, and then we also sent it away for TOF analysis at another third-party lab. So we had 4 data sets to compare to and kind of see what was happening.
And so what's the average discrepancy between your result and the other results?
So we generally, it's really interesting, in the very early rinses when we would expect there to be quite a bit of precursors, we trend a lot closer to a TOF number. So we're higher than a 1633, but as we get down in the rinse cycles, we trended very close to a 1633.
So layman terms, very good.
Yes, we were very happy with the results. I think it definitely showed what we were hoping to in terms of what we were seeing. The data made a lot of sense and we were able to show really close correlation to what the lab was seeing.
What does this kind of project unlock? Is it more airport cleaning, or it's just one thing and then you can do more, and what would be the other applications?
So there's definitely a lot of applications, and we've chosen to start with these AWWF changeouts because they're a really compelling opportunity for us to get the field kit there. We're trying to find applications where there's a really strong value proposition for that and where it's relatively easy to kind of adopt that in. And so that's been the first place that we've looked at. Other applications we have, definitely a big application with treatment technology. So with in-field pilots of treatment tech, right now we're servicing a lot of those customers with our service lab offering, but there's definitely the potential to get the field kit in there. Challenges on that side is that sometimes, depending on the type of work they're doing, it could be landfill leachate samples. It often is. And those are very complicated, really variable. You don't really know what's in there. So it's not a great starting point for a field technology at the moment because we just don't know how it's going to perform in some of those matrices. So that's kind of a future direction for us. But definitely we see AWWF changeouts as a big one. We see site investigations as a big one when you're looking at a site and you need to take a lot of samples and then kind of narrow in on where you might have contamination. That's a big one. Any kind of, groundwater remediation that's happening. We support a lot of earlier stage companies even that are doing R&D and just find that having to send samples to an offsite lab that's not as quick as us can really slow down your R&D. So that's even been a big opportunity for us as, we've sold some field kits into groups that are doing active R&D and just want to be able to that's why we bought our own LCMS, is because we needed to, use that technology to really make sure that we were correlate our results. We knew what we were getting. That was so critical, and getting that data fast was just, paramount for what we were doing.
Have you ever heard of a membrane that refuses to break? It sounds uncommon, but it's true. Meet Bluefoot Membranes, a Belgian company that has developed the first and only unbreakable membrane specifically designed for MBR. If you're new here, membrane bioreactor applications. This technology is setting a new standard in wastewater treatment. Water engineers and industry experts have tested this membrane, and no matter how much they pull and twist, the membrane holds strong. Now, it's not just about membranes, it's also about an award-winning and passionate team that doesn't take impossible as an answer. The people at Bluefoot Membranes are driven by a mission to make wastewater reuse the new standard, united by a shared purpose to leave a blue footprint on the world. So yes, they manufacture cool membranes, but they also push the boundaries of what's possible in MBR technology. To learn more about them, check the link to their website in the description. A big thanks to Bluefoot Membranes for sponsoring this episode, and back to me.
What's the last water trade show you attended?
Myself, personally, I haven't been to one since WEFTech, but...
WEFTech is a good example.
WEFTech's a great one, yeah.
When you were walking through WEFTech, every second or every third booth, let's say, was saying PFAS removal, PFAS treatment.
Yeah.
And all of those are built on the fact that you need to measure what you're doing. If not, you're just doing busy work.
Yep.
So are you just droning under demand, or is there some education of the market to do?
I think there's definitely both. We're definitely seeing a lot of demand, and we're seeing more demand than we can currently fill at the moment. So we've just launched, the field kit was really just launched in January. So it's still fresh. We're just still getting it into customers' hands. So it's been not very long, but we're definitely seeing a lot of demand for it, more than we can fulfill at the moment. But there is definitely still a market education piece, and people are starting to think more about PFAS. What is the analysis analysis mean? And, we spend a lot of time even with our service lab customers just trying to walk them through this, because oftentimes we'll get a customer that's like, I need to measure PFAS. I don't know how. I don't know what I need. What kind of tests are there? What do those show? Does this one mean more than this one? I'm not really sure. Do I want that? Do I want this? Like, they don't know. And so we also spend a lot of time trying to help them, like, okay, what are you trying to do? What do you need? We can help you figure that out, because that's kind of a service that we like to provide people. Is we're not just a lab that gives you a PFAS number. We'll help you understand it, and we're there to support whatever you need, whether that's field kit or whether that's just rapid turnaround testing in our lab. We'll be there to help you with that.
It sounds to me like you live through several product market fits.
Yes.
Like arsenic was a product market fit. Wastewater-based epidemiology was a product market fit, but we're very glad that the market went away, honestly.
Yeah, me too.
And now you're hitting like yet again a product market fit, and probably a stronger, I would guess. What does it change for a company your size, your maturity, let's say? You're 13 years old as a company?
We're 11 years old on Monday.
Okay, you started in 2012, but then the company was founded in 2014. Okay, 1 decade old is still...
It's still a ways, yeah.
You get the product market fit like this one. Does it hit super differently? Like, oh, now it's different problems. We need to ship, we need to build, we need to do quality controls on hardware.
The product market fit that we found here is definitely, feels very different to previous iterations. And not to say that we didn't have good product market fit there, but I think just the scope of the market and the timing. When we were entering the arsenic market, I still think it's true that there aren't good arsenic field technologies. The ones that exist are not very accurate. They're not very good. But, people had kind of learned for many years of how to figure this out. Like this problem wasn't brand new. People had figured out workarounds, ways that they were going to deal with it. So it was very much trying to educate people and, get them on board. And like, yes, you could save money, but, this wasn't really their top problem that they were thinking about. So it was just trickier. Whereas this is like such a different, people are very hungry for it. They know they need it. They're doing a project where they need analysis. The scope is different and kind of the need that people have is different. So yeah, it definitely opens up kind of new challenges for us. Arsenic was a lot more educational, a lot more trying to find, niche customers. You would never go to a WEFTEC and there'd be like 40 booths talking about arsenic. Like that is not how things went. So, so it's a very different, finding the right people was a really big challenge, and finding the decision makers that had these problems, was challenging. Whereas PFAS, that's a little bit of a different problem. So for us, it's definitely around the scaling. I think that's, a challenge. And PFAS is really difficult because it's not as simple as arsenic. And then in arsenic, we measured arsenic and it's one analyte and it's pretty well understood. We measured in a variety of, matrices, drinking water, groundwater, surface water, but it was fairly straightforward. PFAS is not straightforward at all. There are so many different analytes. There's a lot of noise in the market about what analytes matter. We think a total analysis makes sense, but Japan has regulated just AWWA PFAS. So there's that. There's also just the timing right now in the world of like, do we care about the environment anymore? No one's really sure. It's a bit of a weird time. It's a more complicated problem that we're trying to solve, I think, than arsenic was. But I think our challenges really are more around scaling at this moment than they are about, finding that product market fit.
How do you resist the temptation to go all around the places? Because you are, I would believe, right by saying that we should be looking at the total PFAS and not the single ones, because the single ones would always be like a tricky measure. And Europe went that way. Europe is looking at total PFAS, and Europe cares a little bit more about the environment right now than the rest of the world. But Europe is not the same continent, is not the same. So would that be like, oh, we're tempted because everything ticks the boxes there, but at the same time, is it right for a company at your level of maturity to go to a different continent?
That's a big question. We have customers in Europe. These are questions we're definitely, trying to figure out in terms of focus. Like, where do we focus? And the PFAS market, there's definitely a few geographies that are really hot in PFAS. Europe, Australia. There's a lot of work in Japan happening. Then obviously, North America, less so in Canada at the moment, but that's probably going to change. So for right now, I would say we're pretty focused on North America and Europe, and probably, we're focusing more on the market application at the moment. So we're pretty focused on these AWWF changeouts, and some, we're calling it highly impacted groundwater applications. And that's just because of the, the LOD that we have in the field right now. We can't hit drinking water limits. So that we're not applicable to a utility right now. We think that that's definitely going to be a reality in the near-term future.
With the field gas.
Exactly.
But with the lab analysis.
For a service lab, we don't serve service lab of Europe just because, our whole value proposition is a 5-day turnaround guaranteed. And if you have to ship samples from Timbuktu, might not be so quick. We're more servicing North American customers. We have taken some overseas customers on that side. And as long as they can get the samples here pretty quickly, there's a pretty high value prop there as well. But we're a little bit more local, I would say, to North America on the service lab side. But field kit, we're looking abroad as well.
I take that off my chest because Simple Lab is my sponsor. Are you a competitor to Simple Lab, or would you be working together with Simple Lab?
No, I don't really think we're a competitor to Simple Lab. I think they fill, a different niche in the market. I know we had lots of conversations with them, in the past, especially about arsenic and other parameters. They're a little bit more on consumer side of things, like trying to get more access to lab analysis. And, that's definitely a big problem, is just the education and how do you read a lab report and how do you make that process easy and simple. And it's not. But
they could be doing your logistics, for instance.
Totally. Yeah. And maybe there's room in the future for a partnership or something like that. I love what Simple Labs is doing. So it's, I see us definitely more as working in consortium rather than being a direct competitor for sure.
So coming back to the hardware element, a long time ago on that microphone, I spoke with Mina Senkoran from Ketos about developing a hardware sensor, developing it as a woman entrepreneur. And she was basically saying, you're ticking all the wrong boxes. You should not be doing hardware. You should not be a woman entrepreneur, and so far and so on.
The second is we both get classified in that women entrepreneur thing. But third is we both are building hardware. And so again, we get another ding. So the hardware lands up being a third ding.
How much can you relate to that? Like just the hardware part first. How difficult is it to create hardware, and what does it involve in terms of capital needs, and then how do you overcome that?
Yeah, I've always felt a little bit like we tick all the wrong boxes, just in terms of being like, okay, we're quite young when we started. I feel like we're not so young now, but we were young, we're first-time entrepreneurs, we're working in the water sector, so already like, conservative, long business models. You're not just making an app that you can, go crazy in a month. And then we're building deep tech with a hardware component. In terms of how investable we are, like it feels like we tick all the wrong boxes of like, don't do these things. But, I think there's a tremendous like opportunity here as well. And I think if you're solving really important problems that often, there's not going to be an app that solves PFAS for us, unfortunately. I think there's tremendous opportunity there. So yeah, it's been a struggle. I can relate to that. Some days I'm like, maybe we should have picked something a little bit easier, but wouldn't be as fun, I think, if we did that.
You haven't raised much for a company doing hardware specifically, and for what's somewhat a deep tech. So how do you manage to be that bootstrap in your lane?
Yeah, we've been very bootstrapped. We've been extremely creative. Thankfully, these days we're not as creative as we were in the very early days when we did things on nothing. We kind of started the lab with some Amazon and eBay and government surplus equipment that we bought, and friends of ours that had connections at the university that knew a lab that maybe was getting rid of a piece of equipment on a Friday afternoon if we showed up, that kind of thing. So that was how we built our first lab. And it was in this little like dungeon basement that had no cell reception, no windows, no Wi-Fi, no nothing. And it was 140 square feet. So it was kind of like a large bathroom. And that was what we had for the first couple years that we built everything in. And we survived a lot on government grants, got a lot of grants, which is really, really helpful. We got, some accelerator money. We did a bunch of different accelerators, got some funding through that. And we did some really crazy things. We once did a crowdfunding campaign through Alberta Booster. That was this thing from ATB. They had this crowdfunding thing. And so we sold about $25,000 worth of $20 water bottles. And then we had to hand deliver these water bottles because there was no budget for like shipping or anything like that. So we had to like hand deliver them all around the Calgary area. So that was like the hardest 25K we ever worked for. But did a lot of things like that. And then, have done we had a big contract research arm. So one of the things that we've had over the years has been, we have a lot of expertise in building sensors. If you need a sensor for a specific contaminant, we'll do some research on it to see, if we can build something, and we'll build some proof of concepts.
So that means if I'm Hack or Andreas Sauser or my employer, GF Piping System, we have sensors as well. I can go to FREDsense and say, can you help me just at least prototype out something for that specific selenium parameter or...
Exactly. Yeah. And so we've done a few, custom projects over the years with, corporates, government groups, different partners to build different sensors. So that, helped us kind of fund a lot of research and learn a lot of things, kind of figure out what's easy, what's hard, what can we do, that kind of thing. We don't do a lot of that anymore just because it's a huge distraction.
I was going to say,
yeah.
It's a lot of defocusing, yeah.
Yeah, it helped us in the early days kind of like learn a lot and figure out what we wanted to do, but it's something that we don't do a lot of anymore because it just, it resulted in a lot of half-baked things that we spent a lot of time working on, but we could never really get it to an appreciable market launch because we found oftentimes groups would come in and fund, a small project to figure it out. We get some good data, show we could do it. But the next step to really commercialize it, needed a lot more capital. And unless it was a huge market and we could get another player to come in, like sometimes that just didn't all come together.
Coming back to the hardware element and the funding and the bootstrapping, you are live with your field test kits since January.
Yes.
Do you have a factory in Calgary, or how do you do that?
Yeah, we produce them. We have a great partner, Fuel Biomedical in Calgary, and they produce the units for us. So they produce our capture boxes and our fluorometers, and then we make the reagent packs in-house.
So that means you outsource the hardware part and you have the IP on the hardware.
Exactly. Yeah, most of our IP is around, the actual kind of polymer and the actual reagent kits. But yeah, we've developed these kind of the capture box and the fluorometer with Fuel. That's been a really good partnership. And so they produce those right now in small-ish batches at the moment, and then we produce the reagent packs, and that's kind of what we do in more scale.
And so the FREDsense element is standard off the shelf, or is that specific to you?
We developed that for ourselves. Yeah,
Okay.
We did actually look at other options on the market, but wanted something a bit more custom for what we needed to do.
Is that your way to make it work today, or is it your long-term view that you will never do the manufacturing in-house and that's not your lane?
It's something interesting because we manufactured a lot of our arsenic units for a long time, and it's something that I'd rather not do. Like, I think we will probably continue to make the actual reagent packs because those have our secret sauce in them, really with the polymer. But I see we have a really small engineering team. We're a lot more focused on the chemistry and the science and, innovating on that side of things. And so it's just made sense to use partners. If we can find a good partner that we really trust, that's local, to produce some of those, it's actually, we think, cheaper, to do it that way versus have the in-house expertise. Maybe that'll change in the moment, depending on where things go and what we do, but...
And how much you raise.
And how much we raise and, what future systems look like. We may decide to do some of that internally, but it just seems like for us, it's a better use of our time to be optimizing things, building the next thing, dealing with customers, and kind of leave that as a bit, a third-party activity.
Does that mean you're exclusive to that great partner in Calgary, or you could have an equally great partner, I don't know, in Leeuwarden and Netherlands.
Yeah,
and
definitely.
then you're European as well.
If we look at, depending on what we do, in the future, looking at international opportunities, there definitely might be rationale to, manufacture bits of it elsewhere. The things that we're building aren't so custom that they couldn't be built elsewhere. Just what we're doing right now is working, but there's definitely potential in the future to have other groups involved.
That's for your scope. How about your business model? Are you selling the kits and that's it? Or do you also turn that into a service?
So you have a couple of different versions. So we sell the devices. That's one bit of it. And we often sell those with a bit of a service package as well. That's around training, getting people set up. We offer oftentimes a couple of complimentary lab analysis samples so they can, compare data initially when they're doing it. And we try to make that easy for them. So we have that side of things. And then, we have a more service package for some customers if we're doing a little bit more customization or things like that have to happen. And then we also have a rental model as well. So we work with that if we have groups that maybe don't see themselves, maybe it's more like project-based stuff and they don't really want to own the inventory or anything like that, then we have a rental model as well that can have a service package too.
What is the moneymaker today?
Great question. We're still early, but we're seeing interest in both the rental and the buying. It just kind of depends on who the client is. So we're trying to be fairly flexible in terms of what we can offer.
But the rental, again, not that I want to highlight that you're bootstrapped once again, but that means you're immobilizing capital. So you need to have that capital available.
Yep, absolutely. Yeah, and that's definitely, one of the challenges with hardware is that you have to, maintain inventory and you have to time that. That's always the tricky part. You have to time, purchasing the next round of manufactured units, a little bit ahead of when, you need to have the right lead time, but also have to have the capital. And that can become a little bit of a game just to make sure that you're doing this with the right timing.
Are you profitable?
No, not yet. No, we've just started, we're profitable on, the service lab, for example, is profitable in terms of the actual samples that we're running. We have good margins on that. We have good margins on the actual devices, but no, the business itself is not profitable yet.
What is your vision? Where do you want to go with that? Because you're working together with some of the superstars in PFAS destruction. Yeah. I've seen that you work with Clarity. I had Julie on that microphone not so long ago. You're working with Axine. I had Jonathan on that microphone a bit longer ago. And you're working with Ovivo.
Yes.
Ovivo is part of Skion. Skion, every time I speak with Reinhard Hübner, he tells me, we are slowing down with the acquisitions. We only do 4 per year. Like some do 4 in their lifetime. You do 4 per year.
Yeah.
You have something so strongly differentiated and that adds up so strongly to the rest of those players that I'm pretty sure that at some point in the discussion, they must be putting on the table, what if we became the same company at some point? Mm-hmm. Is that something you're looking for, or you really believe you're going to build a giant?
Yeah, I mean, I think we're definitely open open to acquisition options in the future. I think right now we're really proving this out. Definitely a market for it. We're showing that this can meet that need. It can do what customers need it to do. It works. It's scalable. That's kind of where we're at right now. But yeah, we're definitely not against, an acquisition model if we could find, the right partner that would allow us to scale it a lot more effectively than what we can do ourselves. It's definitely not off the table.
Have you been working with Xylem?
Yes, we've done some work in the past with Xylem. Especially we did some work on our arsenic sensor with Xylem as well.
I'm just trying to see who of the usual suspects has been.
Yeah, the water sector is small. We know you generally know all the big players.
So when you work with an Axion, an Clarity, Vivo, what is the scope of work? How do you share the work? What exactly do you do for them?
A lot of these treatment providers are their customers in our service lab. So they're sending us samples and we're turning them around really quickly. But then obviously in all of these cases, there's application in the future for a field kit to fit their needs. Sometimes these customers, the types of water they're dealing with are not amenable to what we can offer on the field kit side right now, or they need super low limits of detection, things like that. But it's definitely something that we're looking to get more customers on the field kit side of things. And we're in discussions with all of our customers about when the right time is to pull the trigger on a field kit deployment.
Where I'm heading is that in your distant roadmap, there's a sensor for water quality, which is not very specifically defined as a sensor for PFAS. But if we now assume that a sensor for PFAS is possible, that would be like the ultimate thing for all these destruction players, because that means that now they are only destroying when they need to destroy, and they're only destroying up to the threshold when they need to destroy. They're not washing water than white if nobody's paying for that.
Right.
So it's very probably a 50% bettering of their OPEX. Like that's the type of magnitude we're discussing here.
Yeah.
So how far are we technically from unlocking something like that?
Like from having
at least a sensor. Then the accuracy is a different question, but at least a sensor.
A sensor like
an online sensor.
An online sensor for PFAS.
Yeah.
Yeah. I mean, it's definitely something that's in our roadmap to build. So I don't think we're too far off. Definitely has its challenges. And I think there's a lot of like, how many analytes does it detect? Does it detect them all equally? Can it pick up on the short chains? What about the long chains? What about the different cationic, anionic? Like there's a lot of complexity there. And so really understanding what that looks like, and even the new emerging PFAS that we're just discovering, is a whole piece of the pie as well. But I don't think we're that far off having a really good indicator anyways of what's happening in terms of PFAS.
You're PFAS centric, and we discussed how you have that little bit of selenium, that little bit of arsenic, but you're PFAS, and even the headline of your website is pretty funny to watch over time with the Wayback Archive, because it's evolving over time, but now it's like fully centered around PFAS. In the same time, emerging contaminants means emerging.
Yep.
So 5-10 years ago, it was 1,4-dioxane, which was super looked at, and then before that, it was endocrine disruptors and microplastics. I mean, there's always a new, unfortunately, trend to ride because there's new concerns, health concerns and environmental concerns. How much of your time do you leave open to look at crazy future stuff?
When we started the company, it was always our hypothesis that we would build like a platform. We would be able to measure a whole bunch of different things. And I think that's very much still in the cards for what we want to do. I'd say right now we're obviously super focused on PFAS, and we see a lot more product development that's going to happen in the PFAS space for sure, around expanding the sensor to get ultra shorts, to potentially look at speciation, to measure more things, to improve the accuracy, all these kind of things, and work in these different matrices for sure. But, beyond that, we are still looking at other options. I'd say it's a very small amount of our time right now. We have the selenium project that's ongoing. We have the arsenic work, but there could be other sensors that emerge in the future. And definitely we've learned a lot about how to build sensors, what they need to look like. So we'd expect future sensors to be quite a lot simpler, but we're trying to keep a little bit of focus just for the moment, with how constrained we are. But definitely in the future with more resources, we think there's potential for other possibilities.
Let's put a date for that future. What is it? Like 2030, 2035, 2040? What is a horizon which is far enough that you say it's the future, but it's still close enough that it's relatable? What would it be for you?
I always think kind of like 5 years, so what would that put us? Like 2030 seems pretty reasonable, but a lot can happen between now and then. So, you never know.
Let's describe FREDsense in 2030. What did you achieve by 2030?
I would like us to have been able to expand the PFAS sensor, to measure a wide range of different analytes, of different matrices, because there's so many different potential matrices. There's also a lot of talk around biosolids, around soil analysis. Like these are other things like totally outside the water space that are important as well. So I think expanding into those different matrices, and really being able to hit those low limits of detections, being able to get down to a single PPT in the field kit is definitely a huge priority for us that I hope by, definitely by 2030, probably a lot sooner than that, but we've been able to do that and that we'd be selling, globally by that point and potentially have other versions of the kit that are, we're looking at things that are maybe there's a version of the kit that's faster that just gives you a yes, no kind of thing. And then maybe there's an inline version that allows you to optimize, something where you have a more, fixed facility, fixed stream that you want to be looking at.
And if I reverse engineer that to the next 12 months, what needs to happen in the next 12 months?
Yeah, the next 12 months is going to be big for us. We've just launched these field kits, which is super exciting. We have one case study out there. We have several more, in the queue that are coming out. It's really for us about proving the value prop in the market, getting these kits into the hands of customers, getting them to use it, learn what works, what doesn't work, figure out any issues, build those data sets and get that out there and start expanding it. And then in the R&D side, we're hyper focused on getting the LOD down and being able to play in some of these more complicated matrices that we see a lot of value in the PFAS space. So that's the next 12 months.
If someone wants to play around with that test kit, where do they get them? Do they reach out to you or is it available in Home Depot? I don't know.
Yeah, no, definitely not. Right now we're just selling direct. They can reach out to us and we have, we'd love to chat with people. We'd love to learn more about people's PFAS problems, what they're looking at, the market's ever evolving. So we're still learning as well about what the best, the strongest use cases are and what people are thinking about.
As always, the links are in the description. So if you want to put your hands on a kit, you just click the link and you're going to be connected with FREDsense.
It's time for the rapid fire questions.
And we got a third guest. I knew she was coming back. But what is the toughest challenge, in your opinion, for a water tech startup?
I think just navigating long sales cycles and, oftentimes maybe having to get into an RFP process or something like that and trying to just time that with what you need to do, I think has been one of the biggest problems.
What would be your best single piece of advice for the founders and managers of the about 1,000 early stage water startups?
I would say to just get, obviously talk to customers as early as possible and make sure you're really thinking critically about what you really have to show to prove that this is scalable. I think about arsenic and that one of the challenges we had with it was just that we would have to really get to a very large scale for this to ever be profitable for us, to sustain the company as a single sensor that we could offer. And that pathway is quite tricky. So I think really just understanding the unit economics of what you need to do and how you could get there and making sure that checks out really early on.
How do you get that wisdom? You're a scientific at the core of it. So how do you get that business acumen?
Yeah, I think just surrounding yourselves with smart people. We've been so fortunate to have, tremendous advisors, tremendous people that have come along on the ride with FREDsense. We have some great board members, different advisors we've met with accelerators, key hires that we've brought in. It's important to kind of figure out where your blind spots are and try to hire really smart people that can help fill those.
What's the drop of knowledge you wish more investors knew about the water sector?
I think just that water, unlike some of the hot trends that we see, and I know people sometimes think, is PFAS a bubble? Is it like AI? Is it like blockchain? Is it like some of these things that we've heard? I think water is, the big thing is it's not going away. I think regardless of what happens, regardless of the political ecosystem, regardless of whatever, I think just the relationship that water has to human health and to what we're doing, I think that is always going to remain pretty true. So I think regardless of what happens, recession, whatever, I think water is still going to be, something that's really important.
When Julie from Clarity was on that microphone, she explained how when she was raising money, she used it as a screening criterion for the investors. If they knew what PFAS was, then she would entertain the conversation. If they didn't know, she would just...
Probably not worth it, yeah.
Do you have
totally
similar experience that also still at that stage, people don't know what PFAS is?
I find it surprising. I think you definitely, live in a bubble, but I do find it surprising just, people at WEFTech, every other booth seemed to be PFAS. And then we still would have people come to the booth and be like, I've never heard of PFAS. I'm like, are you living under a rock? I'm so confused, but okay. So yeah, definitely a little bit.
Super short. Profitability or growth? Don't cheat with profitable growth. Everybody said that. So.
Yeah, I'm gonna say profitability. Yeah.
What's the next profile you'll hire?
I think the next big hire that we're looking for is really someone with some deep expertise in terms of manufacturing and supply chain.
How many people are you at FREDsense right now?
About 25.
When you hire, are you looking for startups experience or sector experience?
Depends on the role. We often look for both. Definitely if we're looking for a more senior person, we really value the startup experience because I find it's just very different than if you've worked in a big, huge resource kind of environment. That's not who we are. But definitely for other roles, we find sometimes more sector, more kind of specific skill set might be more relevant than startup.
Opening new markets or doubling down on the current ones?
Right now, doubling down on the current ones.
What's that tool nobody speaks about, but you couldn't live without? I don't know if it's a tool, but I could not live without that stupid cat.
I would say this seems like a really stupid tool, but it's not really a tool, but it's like a practice. Something that we started to do like, a couple of years ago is every meeting that we have like meeting notes that are automatically generated through our Google Calendar, and the meeting notes, the template for every single meeting note has the company's OKRs in as the template. And so it means that every meeting that we're having, we have to talk about the company's goals and OKRs. Like that's how we structure it. And I find that's just been so radical in terms of like we always used to set goals and then like forget about them. Whereas now it's like the goals are the thing that we're talking about every single week. And that's just such a transformation for everyone in the company to be able to know what the goals are and know that like that's the thing we have to be talking about.
That is an excellent best practice that you should definitely steal. That's never heard of it. That's a very good one. What is the single piece of insight your ideal customer profile needs to hear right now?
Just the time savings that I think we can offer in terms of PFAS analysis. Like there's a huge benefit to having rush analysis, whether it's in field or whether it's, a rush lab. And we think that's going to really change what people can do in the industry.
What are you desperately needing and want to raise an open call for right now?
Desperately, we're definitely in the middle of a fundraising round right now. So I'll give a plug out to that for sure. But we're also just looking for, people with PFAS problems. We'd love to talk to you. We have some applications that we're launching in, always looking for customers in that space, but we're looking to understand more about what other opportunities look like and what, where we can match the use case for and where rapid testing would really make a huge difference.
Last question. What can and should I do for you?
I don't know.
That's good. I love when I have nothing to do. So.
But if you come across anyone, talking about PFAS, definitely send them our way.
Well, it's been a pleasure. Thanks a lot for stopping by.
Oh, thank you. My pleasure.
My little studio. And looking forward to see the next steps.
Awesome. Thank you so much.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.